Hello everyone, my name is Anthony Truss and I teach at Conard High School here in West Hartford, and this is the open house video for engineering and architectural design. This video is going to be a short preview of what we're going to be doing this year. I have approximately 5 minutes that I would like to kind of show you what your son or daughter is going to be doing this year with respects to the Google Classroom, my classroom expectations, and then some of the activities that we're going to be doing. And I hope to see you all during our open house Google Meet as well. So to get started, I want to introduce you to the Google Classroom. As you can see here, all my students are enrolled in the Google Classroom with their Google Meet link if they need to remote in, or sometimes I like to record some things or show some things on the screen, and I typically will use the Google Meet code. The Google Meet code that we're going to be using for open house is a different one that you're going to receive from the school system. So look for that one and not the one that's specifically listed here. One of the things I like to tell my students to do to kind of keep track of what it is that I'm expecting students to know is to kind of use the classwork tab here and to kind of keep track of what assignments have been assigned for the week. As you can see, week 4 has a list of things that need to be done. Week 3, week 2, and then week 1. Some of the due dates are flexible based on the creative element that the projects embrace, and based on the skill set and how well students grasp the learning curve. I'm pretty flexible in terms of when things are turned in, as long as I see students trying and making an effort to get the assignments completed. Extra help is of course always available upon request after school and so forth. I'm available after school Tuesdays and Thursdays with a club that I have until 3:30, so those are always available as well. So some of the things that we're going to be doing this year is focusing obviously on engineering design and architectural design, how to technically communicate ideas of intent, how to solve problems using STEM-based principles and so forth with the tools and technology that we have available in the lab. In our department, the Career Technical Education Department, we try to have a professional approach to our equipment and software. So the equipment and resources, software, and experiences that we provide are as close related to professional careers and industries as best as possible. And we also try to get guest speakers to come in to kind of provide their insight as well. I myself come from industry in the aspect of I've been parallel teaching and working in the engineering industry for now, this is my 18th year. I'm a technical media and marketing director for an aerospace company, and I started in college and have worked my way up through where I am today. So I bring a lot of my experiences that I kind of deal with daily into the classroom as well. So as I said, we focus on technical education, technical communication, and the education of that through the use of a couple different tools, one of which is SolidWorks, which is professionally accepted. And if you're in the technical industry and you're an engineer yourself, you probably have heard of SolidWorks or work with it yourself. If you're unfamiliar with the platform, this is kind of what it looks like. This is one of the earlier versions. This is a three-dimensional modeling platform that lets you create component parts and then assemble them together. As you can see here, this is just a simple food processor. Not so simple when you show an exploded diagram. Here's a simple solid part that was done through a library of hardware, and so forth. So basically this three-dimensional modeling engine will allow us to three-dimensionally visualize engineered parts, learn how engineers communicate using technical drawings, properly dimensioning and calling out values, understanding norms and conventions and standards when it comes to drafting. And just like I said, understanding how to technically communicate either a component part, an assembly, and so forth. I don't have any mechanical drawings in terms of two-dimensional at the moment, but we do focus on orthogonal drawing of front, top, and side with isometric. And we focus also on some hand sketching skills and so forth. Through a series of activities that lead us up to the half-year mark, when we switch gears and we take what we've learned for in the engineering world and we apply it in the architectural design set, where we do focus on blueprints, floor plans, one-line drawings, and property plots and so forth. In the two-dimensional sense, we focus with Chief Architect, and Chief Architect is a three-dimensional design program that lets you create things that you can see right here as an example, In elevation views, you can show textured or not, various obviously drawing styles and renders. And then, like I said, all the way down to where you can create top-down drawings that have been generated from your three-dimensional designs. I embrace a lot of video instruction. So based on what we're doing, either I make the video myself or I will find a video. Chief Architect often offers a lot of quality content that lets students understand and how to share their ideas. So this is just one example of a video that kind of illustrates steps that need to be taken in order to achieve the goals that this video is about. So, like I said, we're going to be focusing on Chief Architect in terms of a software platform, as well as SolidWorks for a 3D design platform. You may have saw one of the pictures I jumped over. We have 3D printers. This is one of our SLA printers. It uses liquid for its 3D printing, and one of the things that it does differently than the FDM is that it provides an exceptional level of detail, and it provides a chemical process so students can actually see the mechanical process on our FDM printers, which is our traditional plastic extruded printer, to our chemical activated SLA photopolymer with UV resin hardening type of chemical reactions that we can talk about. It's also used professionally in the labs, as well as like dental, jewelry, medical, and so forth. So it's just nice to see this in the lab here. We also have a laser engraver. We have a 120 watt laser in 2 of our rooms, so students learn how to create vector-based drawings and then execute their plan and cut out their object to fabricate. As well as we have a CNC router that second-year engineering students will actually be working with as well. So they're going to apply what they learned first year into their second year. Looking at the time, I'm just about out of time, and I would love to speak with you in person. The format that this year is has been set in stone is the remote platform. But if anyone would like to come in and have a conversation, and would like to see this hardware in person, just send me an email and I'd be glad to help you out. I will see you all at the open house meeting when we get together, where I can kind of say hello and introduce myself personally. Have a wonderful day, and I will talk to you then.